Have you ever wondered why flight routes are often curved rather than straight? After all, isn't the straight line path supposed to be the fastest route possible? Well, it turns out the answer to this lies in a vast field known as non-Euclidean geometry. The geometry that we're typically taught in high school is known as Euclidean geometry, which is based off a set of 5 rules known as the 5 postulates. Most of these postulates are pretty straightforward, such as the first postulate, which states that it is possible to draw a straight line connecting any 2 points in a plane. However, the fifth and final postulate has caused controversy for thousands of years because it cannot be proven despite being attempted by several notable mathematicians. The fifth postulate states that given 2 distinct lines that intersect the third line at right angles, the 2 lines will remain the same distance from each other no matter how far we extend them. This seems quite obvious, and it's hard to imagine that anything else would happen. If the lines did not remain the same distance from each other, they would have to either bend towards each other or away from each other. But this wouldn't make sense since lines are straight and can't bend, right? Well, turns out the situation is a bit more complex than this. Take, for example, the surface of a sphere. On a sphere, we can find 2 points that are diametrically opposite of each other, such as the north and south poles on the Earth. These are known as antipodal points. Notice that we can actually draw infinitely many lines along the surface of the sphere connecting these 2 points, whereas on a typical plane, we can only draw 1 line connecting 2 points. And in fact, there are many other obscure properties along the surface of a sphere. For instance, consider walking from the equator up to the North Pole, making a 90-degree turn to the left back down to the equator, and then making another 90-degree turn to the left back to our original position. Looking back at the path we've taken, we notice that we've just formed a triangle with interior angles adding up to 270 degrees. And in fact, every triangle we form along the surface of a sphere results in interior angles that add up to more than 180 degrees. This type of geometry is known as spherical geometry. But what exactly causes these weird properties? Earlier, we mentioned that for the fifth postulate to hold, parallel lines must remain straight and not bend as we extend them. However, something like the surface of a sphere is curved. As a result, no matter how straight of a line we draw on the surface, the lines will still bend. Due to the curvature of the Earth's surface, the most efficient flight routes are actually curved on our maps, which are really just a projection of the Earth's surface onto a flat plane. And it turns out non-Euclidean geometry has more applications than just flight routes on our maps. In his research on the theory of general relativity, Albert Einstein discovered that space-time is actually curved. And because of this curvature, space-time can only be accurately described using non-Euclidean geometry. So, even though non-Euclidean geometry may seem weird and unnatural to us, it might just be the most accurate and natural description of the universe as we know it. Thank you for watching this video. My name is Kevin Tong, and I hope you enjoyed and learned something new today.